Okay, a very good morning. Very good morning to everybody who is here today for our first Form 4 Physics trial class, all right, for our 2022 syllabus. All right, very good morning also to friends from Facebook Live. Okay, thank you for taking your time this early, lovely morning, all right, to be here with me to discover, all right, how this subject can change your life, okay, not only for the next 600 over years, 600 over days, but also for the rest of your life. Okay, for the years that I have been studying, all right, I have been very deeply connected, all right, with the science subjects, right? So when I got the chance to explore this subject, physics, it really blew my mind, okay? Because there is a lot of things for you to discover about life in this subject, not only about science, but also really about life, right? Because from the moment that we are born, a lot of the things that we see, all right, in our surrounding is actually a phenomenon of physics, all right? From the moment you open your eyes itself, to be able to see your parents, to be able to see light, that itself is the magic of physics. All right, there is a lot more that you'll be learning in this new syllabus, especially in KSSM. They have designed, all right, the syllabus so that you are able to explore many branches in physics. Yes, physics is actually a very wide branch. All right, physics is a very wide branch, and I would say it is one of the earliest branches of science to be studied in detail. All right, on a small scale, on a small level, on a microscopic level. And even smaller than that, in the quantum scale, yeah, and in the largest scale you could possibly think of, the theory of the universe, which attracted the minds of Albert Einstein, the minds of Isaac Newton, the minds of Michael Faraday, the minds of, Nicholas Copernicus, the minds of Michio Kaku, all right? And even going back into the days when theories of physics started from people like Aristotle. Okay, Aristotle. And then for the last few hundreds of years, we have discovered more and more about how the world works, all right? In the beginning, Aristotle proposed that how things, when they move, they are unable to slow down immediately, right? And if you slow down immediately or you stop immediately, that thing keeps on moving. Let me give you an example, right? If let's say you are sitting in a car, right? When we are moving, what happens is your body moves together with the car. Yes, the car's moving, you were in the car, you were moving with the car, right? So let's say if suddenly a deer or a buffalo runs by, you suddenly stop the car, what happens? You will feel, right, a force pushing you to the front. And if you are not wearing a seatbelt, that is when you will fly out of the car, breaking your windshield. Okay, that is actually a phenomenon, yeah, in physics, right? Because we say you were moving together with the car, and all of a sudden the car stops moving, but your body still contains all the energy and all the force. You are unable to overcome this energy and force, and you will continue your movement, we say. So this is one of the earliest topics you will learn from 4KSSM, all right? We call it inertia. And this is one of the earliest things that was discovered by even the Greek scientists. Aristotle proposed that things stop moving when they get tired. That was the bare basic of physics, the bare basic of science, really. It's just a matter of combining observation with the logic of mankind at that time. That humans will stop when they get tired, that humans will rest when they get tired, right? Aristotle said that objects will stop when they get tired, right? It's bare observation, bare logic, lovely, right? At the time, there was about 800 years ago, perfect. And until today, right, due to the progress of studies by people like Isaac Newton, then we discovered that this phenomenon we're talking about here is inertia. All right, that objects contain energy, and when they move, they will continue moving unless something external happen. For example, if they lose the energy through friction, or for example, if someone pushes the object and it moves faster. Yes, an object continues moving unless an external force is applied, they call it. Yeah, so you can see how different the world looks like, okay, from the early ages until today. And today, wow, the physicists are even more imaginative, are even more ambitious, right? Just last year during Christmas, I would say that was the most recent feat, right? The most recent achievement, right, in the world of physics, right? That we were able to send up the world's second best, as in it's the world best. It's the second time we sent it. It is the best telescope that mankind has ever invented, the James Webb Space Telescope. All right, on the nickname we call it the Golden Eye. Those of you who have been following news about astronomy, yes, all right, an infrared telescope, right, able to capture light, yeah, because telescope, right, we used to see light, right, able to capture light from very, very far away and very, very long ago. Very, very long ago. Wow. Why am I talking about telescope being able to see very, very long ago? Incredible. Incredible. Telescope does not only see light, you know, it can actually see into the past. The past, you know. And when I say the past, I'm not talking about a second ago, I'm not talking about 2 seconds ago, I'm talking about millions of years ago. Yes, that telescope should be able to see, yeah, into the early days of the world, right, of the universe, just right after the Big Bang happened. As the Big Bang, another concept, right? Very interesting concept, right? The beginning of the universes. Now let's talk about why this telescope, this powerful telescope, is able to see into the past. Now, do you know, students? Whenever we look into the mirror, we are actually looking at the past. We are looking at ourselves in the past, right? If you are standing very close to the mirror, of course, you are looking at a more recent version of yourself. But the further you are away from the mirror, you are actually looking into an older version of yourself. So let me explain what do I mean. I take a look. I hope everyone on Facebook can see the whiteboard, right? So what we have here is this, yeah? So let me draw 2 mirrors, right? Just one mirror. This is your mirror, and this you are here. Okay, now in PT3, you already learned about this fact. In Form 1, Chapter 9, in fact, Chapter 8, sorry. Light is the fastest thing that human knows. It travels at the speed of 3 times 10 power 8 kilometers per second. 3 times 10 power 8 meters per second. Right? This one you already know. That means light has a speed. Light takes time to travel. So what actually happens is, you are the object. Right? You are the object. A mirror creates the image of an object. So in the beginning, your light, the light that is coming off you, okay, so let's talk about even before that, right? How does the light even appear on your body? That comes from the sun, isn't it? We say the sun is the ultimate source of energy. The light energy shines onto your body, making your body able to be seen. And the mirror wants to capture that light. The light will travel to the mirror, and then we say it will reflect. Reflection. It will reflect back into your eyes, of course. If we take a look at this part here, you can see that this is quite a distance. If it's a meter, it's a meter. If it's 3 meters, it's 3 meters. If it's 10 meters, it's 10 meters. You say it's a distance. In physics, nothing is negligible. Even 0.5 cm is 0.5 cm, right? This is a distance. And where there is distance, there is speed. Where there is speed, there is time. It takes time. It takes time for the light to travel. So let's just imagine that the light takes a second to travel to the mirror, and it takes a second back to travel into your eyes. In total, what has the light done? The light has just traveled 2 seconds. Now, the time now is 11:02. Let's say you are standing here at 11:02:00 a.m. Right? So 11 hours and 2 minutes and 00 seconds now. The light travels 1 second to the mirror. It takes a second back travel to your eyes. By the time it finished traveling, it should be 11:02:02 a.m. Agree? 2 seconds has passed. But tell me, are you looking at yourself at 11:02:00 or are you looking at yourself 11:02:02? The image. Talk about the image. Did we capture the image at 11:02:00 or at 02:02? That's the question. Yes. Yeah. Friends on Zoom, yes. 11:02:00. You're correct. You were looking at yourself at 12:02:00. That means at 11:02:02, essentially, you were looking at 2 seconds ago. Yourself 2 seconds ago. Fantastic. On a small scale, this is what it is. But on a large scale, then that is when it becomes powerful. You know, the universe is a very big place. Even astronomers today, they do not know where is the boundary of the universe. They don't know where is the end of the universe. No one can tell you where is the universe. Only God himself, right? And the universe is expanding. The boundary is expanding. The fabric of space is expanding, right? And that means the universe is essentially very big, right? We even make a unit for it. Distance in light years. Distance that light is able to travel in a year, right? So it's very, very far. Now, let's bring this thing to a bigger scale. Let's talk about the James Webb telescope. No, let's talk about the sun. Let's talk about the sun and the earth. Now, we know the sun, again, is the ultimate energy of Earth, right? And you are here. Some 150 million kilometers away. Perfect. So you are here, right? Let's say you are here. Now, as I say, the distance between the sun and the earth is some 150 million kilometers in full form. It's like this, you know. If you were to calculate this against the speed of light, because light is light, right? It would take 8 minutes for light to travel, a complete 8 minutes. Which means now it is 11:05 a.m. If it takes 8 minutes to travel into your eyes, 11:05 plus 8 minutes, that is at 11:13 a.m. That means if the sun were to release some light at 11:05 now, it will only reach your eyes at 11:13. At 11:13, are you looking at the sun in the 11:13 situation? No. You are looking at the sun at the 11:05 situation. Do you know what that means? That means that at 11:05, if the sun suddenly exploded, you would not know No, you will not know for 8 minutes. You will not hear a sound. You will not feel a thing. You will not see a thing, because light is the fastest. Before light reaches, nothing can reach. You cannot hear nothing. You cannot see nothing. It will be a beautiful day. At 11:13, what happens? Boom! Everything will come. You will see the explosion. You will hear that. You will feel the explosion. Probably die from the explosion. Hey, but that's 8 minutes delay. 8 minutes later only, you know. So, question, at 11:13, did the sun explode at 11:13? No. The sun exploded at 11:05. You get to see the light at 11:13. That's why you only know about the explosion at 11:13. This itself, students, is already captivating, agree? Yeah? I hope, friends on Facebook, you are having a good time. Yeah. This is, students, the power of physics. Yeah? This is the power of physics. Now, of course, at your level, at Form 4 and Form 5, this is not going to be so much important, but this, of course, is eventually what you are going to learn if you dive deeper into the world of physics. In the beginning, of course, before you even reach this part, you've got to talk about mechanics. How do things move? How does an aeroplane fly? How do cars move? How do you suck on a straw? How do comets move in the sky? Right? Things like this. Only then, slowly, you will arrive at this. And let's talk about James Webb, right? I haven't finished my story yet. James Webb. James Webb is a telescope which scientists try to look into the past. How is that able to happen? Let's draw another model. Let's say somewhere far in a distant galaxy, something is happening there. We don't know. I don't know. You don't know. They don't know. No one knows, right? Something's happening there. The Big Bang Theory, right, itself is a concept which, you know, it proposes that, you know, the sun, I mean, the outer space, I mean, the universe came from a very big explosion, right? And then, of course, there we are, very far away, right? Earth, solar system, Milky Way galaxy even, and let's say the James Webb telescope is somewhere here. Now, I use the mirror, a 2-second explanation. I use the sun, an 8-minute explanation. That was in meters, that was in kilometers. Over here, we are not talking about meters, kilometers, we're talking about light years. Light years. So imagine how long this would take for the light to reach. So we say something has happened here, isn't it? An explosion, something has happened, right? I just say something because I don't know what's happening here. And this is n million of years ago, no? Something happened. That means now, at this exact moment, of course, it's already different. It's already different. But this thing that happened million of years ago, have we seen it? Have we seen it yet? No. Why? Because it's still traveling. It is still traveling in the distant galaxy, trying to reach our eyes. Yes. It is still, the light is still traveling and traveling and traveling. Probably somewhere here, which the James Webb telescope is trying to wait and wait and wait and wait until the image pops up on the James Webb telescope. So by then, 2022. Are we looking at 2022 at this galaxy? No. We are taking a look at millions of years ago in this galaxy. because the light took millions of years to travel to our eyes. And that is how we look into the past. That also means if there's any alien life out there that does the same thing to us, they send out a telescope here, they want to look at us, do you know what will happen to them? Millions of years ago, during the dinosaur age of the earth, during the time of ancient Egypt when the pyramids were formed, yeah, that time, the image is still traveling, the picture of the dinosaur, the picture of the ancient pyramids, the picture of the Great Wall of China, the picture of the meteor hit on Earth or whatever it is, millions of years ago, is still traveling. Now, let's say it reaches their telescope. They will be looking at Earth in the past. Their telescope will appear an image of dinosaur. Same thing happens to them. They look into the past of us. But, of course, for us, the era of the dinosaurs already passed. Is it? That's the fascinating part of physics. At times, it really makes your mind, you cannot comprehend, really. So this is, of course, also a fundamental building block to Einstein's famous theory of relativity, that time is relative to the person observing it. There you go. This is the theory. Yes. Almost $10 billion went into this project. Hopefully it can help scientists to discover more about the beginnings of mankind, the beginnings of the universe, and to create a breakthrough in the world of science. Of course, this is physics on a large scale. Like I said, physics also happen on a small scale, right? In the quantum level, in the atomic level, taking a look at how the atoms behave. In the past, we only knew that the smallest particle, right? We call it particle. The smallest particle we know is the atom. But then we discovered that inside the atom, there were even smaller particles, right? The protons, neutrons, and electrons. What you may not know is there are a team of scientists who are working very hard today in Switzerland. They are trying to discover even smaller particles. All right? Even smaller particles, even smaller than the protons, neutrons, and electrons. The quarks, the Yang-Mills particles, the sparkles, superparticles, the Higgs boson. Yes, they are looking to come up with the entire theory of particles. Because when you understand all the particles, they think that they can understand everything about the world. Because everything essentially is made out of those particles. So to understand the thing, you understand the particles. And what we have just discussed there is this theory, the string theory, worked on by Dr. Michio Kaku and his team of scientists in Switzerland. He proposed that particles don't only behave as spherical particles. Particles are actually like a rubber band that vibrates at different frequencies. Every particle has their own unique frequency. And that one we call the string theory. Okay, so far I've already introduced you to the biggest scale of physics, to the smaller scale of physics, Your job, students, in the next 2 years, your job is to learn everything in between. Okay. We have learned a lot of physics the last 3 years of your life. In Form 1, you talked about light, reflection, refraction, diffraction, dispersion of light, scattering of light. Chapter 5, the kinetic theory of matter. In Form 2, you talk about sound, talk about heat. In Form 3, you talked about radioactivity, electromagnetism, transformers. Those taking ASK, you learned about nodes, logic gates, capacitors, transistors. All of these things are the works of physics. Without physics, we won't be here today, because there will not be any computers, there will not be any internet, there will not be any microphones. I won't be able to talk to you from far away. That is the wonder of physics. Now, let me tell you what I'm going to do in my class, right? Of course, I hope my presentation so far has already amazed you, right? These are the same exact things which really got me into physics, so I thought I wanted to share it with you. It's not my favorite subject, right? No, it's not my best subject, but it's my favorite subject, right? Now I'm going to do my class, very simple. 1 hour 15 minutes every week. I'm going to deliver very high impact lessons to you, right? I'm going to focus on explaining the theory. I'm going to focus on giving you examples. And we're going to work on some questions together. The notes that I'll be using are very compact and very high impact. And those of you from my PT3 class, you already know that I have special techniques, secret techniques, I call it, to memorize and to remember things. One of the topics you will learn in Form 4 is the electromagnetic spectrum. I'm sure some of you already encountered this in PT3. Now, the electromagnetic spectrum is not something easy to understand. You need to understand the purpose of it, the sequence of it, and the values of it. And I have a way to memorize the entire electromagnetic spectrum. And not just that. Okay, even more subtopics, techniques of memorization. Past year exam papers, I'm going to cover all the past year exam papers with you. All right, so if you are a Form 5 student watching this live, Form 5 physics I'm also conducting, all right, where we will do a lot of drilling for SPM. All right. There's truth to be told, all right. It was not very long ago since I took my SPM. I mean, it's not last year, it's not 2 years ago, it's not 3 years ago, but it's not a long while ago. So I still freshly remember what it means to be a student, what it means to study, what it means to actually learn. I know your limits, I know your capacity, I know your will, I know your strength, I know your weaknesses, I know your challenges. And I think I can help you in the correct way. I will not force you to do things beyond your boundaries. And I will not let you go if I know you are not working at your full capacity. By the next 600 over days, if you follow class closely, I'm sure 1 out of the 9 A plus will already be in your hands. Because we're going to do hell a lot of work. Yes. I'm going to replicate what I did to myself to all of you. Back then, I essentially covered all the state papers for the past 10 years. Essentially, all the state papers. Paper 1, paper 2, paper 3. And back then, physics had 50 objective questions. On average, a day, I complete hundreds of questions. To the point that I even recognize which question is from which state, which year. And that's what I'm going to do to all of you. That's what I'm going to do to all of you. The seniors this year in Form 4, they have done a fantastic job in their final exams. All right. A lot of them, very motivated students, they WhatsApp me, all right, day and night to ask about questions. And I'm very happy to answer them. All right, because I want them to discover. I want them to discover, I want them to explore. And the only way to explore is when you ask. The inquisitive mindset was what brought us out of the darkest days of mankind. The era of Renaissance started because people asked questions. Gravity itself was a product of someone asking why an apple will fall from a tree. And if an apple falls from a tree, why doesn't the moon also fall from the tree? Asking questions. So if you think yourself as an inquisitive student, dare to ask, dare to explore, dare to challenge, you are at the right place. Okay, students? All right. So soon, I'm sure you are going to go into your holidays. Your textbooks are going to come. Have a look through, all right? Find out what you're going to be learning. And I hope to see you in my class come March. The new syllabus in 2022 will start the first week of March, all right? And registrations are already open. Friends on Zoom, friends on Facebook, if you have not done your registration, we offer subjects, almost all of the major subjects from the science side, physics, biology, chemistry, additional maths, both in bilingual, Bahasa, and from the arts side for your friends, prinsip perakaunan, economy, perniagaan, on top of all the trust subjects, BM, English, science, maths, sejarah. All of us are reference book authors, school teachers, university lecturers, seminar speakers, school examiners. And we are ready to help you. You have made the right choice to be here today. You have made the right choice. Once, I'm sure you can make the right choice the second time. So do let us know if you are interested to join our classes. I think my time is almost up. All right. I had a really fantastic time explaining this to you. All right. Every time I get to make this presentation, it really relight my passion for this subject. And I hope I have started to light up yours. In the afternoon later, I'll be doing another session for Form 4 Chemistry Introduction, because I'll be teaching for Form 4 Physics and Form 4 Chemistry. I only specialize in science subjects. So I hope to see you all later on in the afternoon, where I'll be talking about the wonders of chemistry. Maybe for a lot of you, not so much interesting. Chemistry is quite a dead subject. Not as interesting as physics, of course, but there are still things that you can look forward to in chemistry. Earlier this morning, a session on biology conducted by a very experienced Mr. Paul. Not over 30 years of his life. And in those years, he has also produced over 30 reference books. Yes, given seminars, the top schools, high caliber schools in Malaysia, right? MRSMs, SDPs, and he's here to help you. So I guess this is the end of our time here today for our Form 4 Physics presentation. I hope all of you have enjoyed it. If you have any questions, please feel free to drop us a message on Facebook, on our customer service lines, and I hope to see you, everyone, at our class beginning the first week of March. If you have any friends, of course, bring them along so we can have a very fun and incredible, exciting class together. From the bottom of my heart, thank you very much for coming. Have a good weekend. Those who are done with final exam, take a good rest. Those who have not, have a wonderful time doing your revision. Take care, and I'll see you the next time. Goodbye.